by this. What is the maximum value of f on the interval 0, 6?
So you start by finding the derivative, right?
I actually like trying the value first in the original function.
Oh, okay.
Getting those two values first. Would you have a calculator to do this, or would it be by hand?
No, he said no calculator.
No calculator. So that could be, that could be a little bit. I mean, the first one's not too bad. I mean, 0 cubed minus 6 times 0 squared minus 15 times 0 equals 0. The next one, though, 6 cubed minus 6 times 6 cubed minus 15 times 6. I'm sorry, 6 squared here. So this middle one is actually 6 cubed. 6 cubed minus 6 cubed is 0. And then 15 times 6 is 90, minus 90.
Okay.
You want to take advantage of this technique. So then you do take the derivative because you're looking for critical points.
3x squared minus 12x minus 15.
Set it equal to 0, factor out a 3. There's often a GCF. You may even remember our lessons doing that a couple of years ago. Like, that's why it was so important to get that stuff down, so that when you do this now, it's
4x minus 5.
Yeah, so the two critical points are at 5 and -1. Okay, and you check if they're in that interval. Check if in 0 to 6, because -1 is not. And
-1.
yeah, so you say, oh, I can't consider that one. And what I should have done is left enough room to try f of 5 back in the original, like up here, f of 5. So you take this number and you go back and you try it. So it's 5 cubed minus 6 times 5 squared minus 15 times 5. Okay, and let's see here. So 5 cubed is 125. 5 squared is 25 times 6 is minus 150. 15 times 5 is minus 75. So this ends up being minus 100 when all said and done. Now you're looking for the max. So the maximum value is 0. It happens to occur at 0. This, just to be clear, this is for the y value.
So you have to look. I see where the highest one. Okay.
Yeah, you're looking at those 3 y values and deciding which one is the largest.
Okay.
I'm surprised they don't ask for the minimum.
The minimum would be 5 then.
The minimum is -100. It occurs at x equals 5. So if it said what is the minimum value of f, it's minus 100.
Oh, okay. But so if this one asks what is the maximum, where does the maximum value?
Yes, exactly. Yes. Okay. And what is the maximum actually is 0.
Also so 0. Yeah.
Yes.
Okay.
Let me just scan ahead here to see if they perhaps ask one more like it. Does not. Okay, we'll just go through.
We can ask another. We can do another one like it, maybe. Like, just make one up.
Yeah, I can certainly do that. Okay, so let's say f of x equals minus x cubed minus 6x squared. I think this works plus 18. Actually, let's do minus 18x.
Okay.
And let's just, I don't know what the values are. Let's just do the derivative first on this. Okay. So minus 3x squared minus 12x minus 18. And I factored in a -3, so we get x squared plus 4x plus 6. This one does not factor unless I change this to 15. Nope, I'm gonna change it to, sorry, let me just change them here real quick. Let's make this 4. And so let me make this minus 4x. minus 4. It's got to be 12. I'm sorry. It's got to be 12. All right, there we go. Now we have it down.
So that's -3 x plus 2 squared. So it's x equals -2.
Yeah, so let's say in the interval from -3 to 0.
Okay.
Okay.
So then we plug in your -2.
So you got to find all 3 of these. You know, be very, very careful with your sign on that.
6 of -2.
And again, back in the original, not in the intermediates.
Yes. Okay, so this is 16. 424. Then 0. I did not get 8 for -2.
Okay. Let me check that. So let's go -3. Oh, I used the wrong ones. No, wait, minus x cubed. Yeah, okay, so it's -3 cubed negative -6 times -3.
Well,
squared.
no, for the -2 one.
Oh, for the -2. Yes, thank you. -2.
I haven't done the -3 yet. So I don't know, but...
Okay. -12 times -2. Okay, so I see this is -8, but then that becomes +8. This is 4 times this, so -24.
Oh wait, that's the problem. I just
Yeah.
I got the 24 and the 24. I just got the wrong number for that.
Okay.
Would it be oh, never mind. Okay. So then 3 negative cubed. Oh my god. Okay. Squared -12 times -3. So then 3 cubed is 27, right? No.
Yes, well, it's negative. It's
Yeah,
it's,
okay. So -27, and then that's 9. 9 times 6, -6 is 4. So negative, that first part isn't, that's -27, right?
but then you negate it, so it's +27. Because you cube it first, then negate it.
And then it's,
This is 9 times -6 and -54.
right, got that.
And then plus 36.
Okay.
That all makes 9.
Okay. So your max is -9.
Oh, actually, let me, I don't know how easy, you've got these numbers down, right?
Yes, now.
Okay, so these are the 4 questions they could ask you, and they're out of order. If you would like, I can put them in order, but I thought maybe that would be better. What is the maximum value of f? That
9.
is yes, that is 9. Okay, where does the minimum value of f occur?
0.
Okay, what is the minimum value of f?
0.
Where does the maximum value of f occur?
-3.
3. Okay, now if we made a really quick sketch of this, -3, 9, -2, 8, and 0, 0. Okay. Because the derivative is 0 here of the original, well, actually we don't know anything. I was suggesting that we could do something else, but let that exclude. Let's just try to forget that. We can't, because we can't do anything useful with that. So, okay, let's move on to the graph and the next question, which is a graph. I think there's a lot of things last night that didn't seem clear. So maybe they're clearer now. This is the derivative. This is the graph of the derivative.
Yes.
Okay. So f prime of x equals 0 at 1, 2, 3 places.
Okay.
Agree with that? Do you see that? So
yeah.
And if we were to make a number line sign chart thing here of the derivative, what sign goes in each of these regions? Like what goes in this region right here? What is the derivative? Positive, negative, negative, positive. Okay.
Yeah.
Okay. And we said yesterday, if it goes from minus to plus, what is that called?
From minus to plus, that's a maximum.
So I don't know if you can see this, but I'm trying to show it tracing, down and then up.
Oh, minimum. Yeah.
Yes. And if it goes plus to minus.
So that's.
So how many of these occur? So this minus to plus is something. This plus to minus is something. And then this minus to plus is something.
So so 2.
Well, okay. So what happens here what happens at this point when it goes minus to plus? Is that a min or a max?
It's a min.
Okay. So there's a min there. How about plus to minus?
Max.
How about minus to plus?
Min.
Okay. So there's 2 mins and 1 max.
Oh, okay. So, okay.
Let me have you do the same analysis when you get this copy down. Oh, and I'm sorry, I don't remember if I'm really bad at actually circling the right answers. I guess it's that one. I didn't actually select the answer on A from number 1. Maybe I did.
It was A, I think. Yeah.
Yeah. Okay. Do you want me to give you another graph here to try this?
Yeah, sure.
Okay. Do you want me to make it more difficult or same difficulty?
Whatever you please.
Okay, let's do the same difficulty and then I'll make one more difficult.
Okay.
Okay. All right, and so I want you to tell me number of critical points. This is f prime of x.
So there's 3 critical points.
And then go ahead and decide how many mins and maxes there are.
Okay, so there's 1 there. Positive, negative. Okay, so I need to make a switch. Do. Three. Oh wait.
So I'm looking for there are 3 mins and and 0 maxes,
Yeah.
or 1 min and 2 maxes. And I still recommend making a sign chart.
So then in the sign chart, it's negative, positive, negative, positive, right?
Yep.
So then there's.
So what's happening at the first one? It's going decreasing to increasing. Is that a min or a max?
That's a min.
Okay.
And then we got 1 max and then a min. So 2 mins, 1 max.
Yes. All right, so there's other things that could happen. And that's why I asked if you wanted one more difficult on this. Is that okay? Did you
Yeah.
get this done? Okay, so let's do another one here. Okay, so let's say you come down, touch, come down, touch, and go back up. Okay.
So there's two critical points only?
There's more than that. Anywhere it touches
Oh, it doesn't have to cross?
or crosses is one. So there's
Oh,
one here. We'll call it A, B, C, and D. And you do the same thing. You do the
okay, so it's positive, negative, negative, positive, positive.
yes.
Okay, so then this is a increasing, decreasing, increasing. So then there's a max at one max here, two max, one min. Oh,
It only if it changes from positive, negative, or negative positives. There's nothing at these other points. Like plus to plus is nothing, minus to minus is nothing.
okay. So just a
Yeah, A and D.
C, right?
C. Yeah, sorry. Yes, A and C.
Okay,
Would you like another one that's kind of like got a little more obscureness to it that you
sure.
could see? Okay. All right. Okay, so could do that. Okay, so this is just to be clear, this is meant to be a vertical.
Okay,
And the reason that's important is it's not a critical point, but it is a point that you have to like identify on your chart here.
okay.
Okay, so like A,
So
B,
so
sorry.
A and D are zeros, right?
A and D is something good, but B it crosses, but there's a vertical tangent there. So nothing happens when that
But like
occurs.
when you're like so, but like A and D are your zeros. What is C?
C is a zero also.
But it doesn't cross.
It touches though.
The zero can be one that touches too.
Just like in the previous one. See how these touch?
But that's just a crit.
Touches are critical points. So to touch.
But is it a zero? Is a critical point the same thing as a zero?
Yes.
Okay. So then you're going.
But B is also problematic because it's a vertical tangent. It's got a vertical thing going on.
Yeah. Okay.
And then that's really bad. Like you have to include it, but like just because you're even though this happens, nothing occurs here at B because of this fact that it's vertical.
Right. Okay. So then there's a. So then there's two maxes and one min.
No, like what it's trying to say is like B is nothing. Like you ignore B. You can't do anything at B.
One max. Wait, two maxes then.
Yeah. Yes, two maxes.
A and D.
Mm-hmm. But nothing there and nothing there. Yeah.
Okay.
Yeah.
Okay.
All right. So let's go to the next one. Okay, f is a function such that the derivative is natural log of x over x, and the second derivative is 1 minus natural log of x over x squared. Okay. There's a lot of like things going on here in this multiple choice. So like they're asking you to like do a sign chart for the first derivative and then a sign chart for the second derivative and like match up what you think is right to this here.
Okay.
So they've already done the work for you, which I guess is nice. So where is f prime of x? And this is what I think is really confusing, is like, because for so long you've been told like, look where the derivative is equal to 0, but you also need to look where the derivative is undefined. And that could either be a domain issue or like division by 0 or like that kind of stuff.
Okay.
So where is f prime, where is the natural log of x over x equal to 0? It's equal to 0 when the numerator is 0. Where is the numerator 0? The natural log of 1 is 0. So when x equals 1, that's a critical point.
Okay.
Okay. But you also need to know like, when is the derivative undefined? So let's look at the domain. So do you remember the domain of natural log?
No.
Okay, so natural log looks like this. So its domain is from 0 to infinity.
I know the derivative of natural log.
Well, you got to know this because your sign chart starts at 0. It doesn't start at negative infinity.
Okay.
Okay. And then furthermore, like you can't divide by 0, so that's why that point's excluded. So your sign chart is here. Like you have to pick something from 0 to 1 and then from 1 to infinity.
Oh, because of the critical. Okay.
Yes. So like pick like 10. The natural log of 10 is a positive number. Positive number of positive number is positive. So that's positive here. Pick 1/2. The natural log of 1/2 is negative. It's negative because the breakpoint is at 1. So like anything below, anything less than 1 but greater than 0, the natural log of it's a negative number. Negative number over 1/2, negative over positive is negative.
Mhm.
Okay. So then you got to do the same thing for the second derivative. So they give you the second derivative, thank goodness, because you know that there's more work to do. So the second derivative is 1 minus natural log of x over x squared. We got to figure out where that equals 0. Where does the numerator equal 0 on that one? Any idea? So we're looking for, we're solving 1 minus natural log of x equals 0. The natural log of e is 1.
Oh my God.
Okay. So this is just reminder stuff. So when e is that critical point, when x equals e, and that's your critical point. E is about, it's about 2 point. Yep.
Okay.
E is about 2.7. So just to get that kind of lined up nicely. Okay. So we got to check numbers again. And like, if you're not sure what E is, or like, what if it was E squared? E squared is like 8 point something. Choose a number much further away to avoid like issues like 10 or 50, just to kind of help. So the natural log of 50 is like, it's a number bigger than 1. We'll just say that. So this is negative, this is positive, so it's negative here. But the natural log of, say, like, I don't know, 1/2 is negative. And then
do 1.
Say that again.
Can you just do 1?
Sure. So the natural log of 1 is 0. 1 minus 0 is 1. So you got a positive up top over a positive. Okay.
Okay.
So I find the multiple choice here to be very difficult because you can't just like, it would be easier in words to say from 0 to 1, like it's decreasing, and from 1 to infinity it's increasing, and from 0 to e it's increasing, and from e to infinity it's I'm sorry, concave down, concave up.
So
but instead you go ahead.
First derivative is when you use increasing, decreasing. Second,
That's right.
concave up.
That's right. So, but if you look at the multiple choice, they all are for greater than 1. So let's look at greater than 1, it's increasing.
Mhm.
So that means that that's not true and that's not true. So we're down to C and D. Okay. And then what is happening greater than E? So greater than E, it's concave down. That's
Wait,
the
are you
second.
only looking at the second derivative part?
Yes, you want to look at the second derivative for concavity.
Oh, I see. Never mind. Okay.
Okay, so this is the correct answer because it is concave down for X greater than E.
Okay.
And that comes again from here, right here, greater than E, it's doing
Right.
that.
Okay.
All right, so that's yeah, that's that, I guess.
Perfect.
All right, so let's look at the next one, question 4. Oh no, it's one of these one only, two. These are horrible.
Oh no.
Okay, we'll be okay though. So okay, they're giving you now. This is different. They're giving you the original function finally. Like we
Okay.
haven't done one of those in a while. So like the rules change, right? Like you can't be like, oh, it's always above 0, so it's increasing. No, it's increasing from A to C because it's going up and to the right.
Well, isn't it when you're talking about first the original, it's just like positive, negative?
No, not like increasing on the original means that it's going up and to the right. So
Okay.
that's the first. So they're asking here, on which interval is the derivative greater than 0? And what that means is it's increasing. This means increasing. Y is increasing.
Okay.
So where's Y increasing? It's increasing from A to C.
Mhm.
Okay,
And
so that's true. Like it's increasing there, but not there. So 3
okay.
is out. Okay, so like 1 and 2 so far are true. They're looking good. Now, second derivative, less than 0, that means it's concave. Y is concave down.
C to D.
So hold, yes, so well, from B to C, right? I think you said C to B, so we go left to right.
I said C to D.
Oh, C to D. So yeah, that is true. It is concave down there, but it's also concave down here from B to C.
Are you going backwards?
No, you just look at anywhere from A to D.
But B to C, we just said was concave up.
No, B to C is increasing.
So how is it concave down if it's
Okay, so let's go through the 4. Okay, so this is increasing concave up. This is increasing concave down. Decreasing concave up. Decreasing concave down. You have to know these 4 really well so that you can identify them.
Oh, I don't understand the increasing down and the decreasing up. Those don't. How is that?
So again, like recall that increasing means it's going up and to the right.
Yeah.
Is this one down here going up and to the right?
Yeah.
So it's increasing.
But why the concave down?
Because it doesn't hold water. I mean, or so the down refers to the rate of change of the derivative, but you don't want, that's usually unclear. Like, do you agree that this would not hold water?
Yeah.
Okay. So that's like, I mean, we could, that there's a break point, right? Like if this graph on the left was connected to this graph on the right, like maybe that's what you want to see, but they break there because they're both concave down. But
so if it can hold, it's up. Okay.
yeah, and decreasing is going down and to the right. So is this one going down and to the right? Yeah, I mean, it goes right and then down, but it's ultimately down and to the right.
Yeah, okay.
These, this is like, remember those, like I would draw for you, I think we did this at one point where there's 4 graphs, like a greater than 0 and even
Yeah,
polynomial. These are like that. You got to know these really well. So because when we look at the graph here, you have to say from B to C, and maybe that's how we should do this. So from A to B, it's concave up and it's increasing.
okay,
From B to C, it's concave down and it's increasing because it's going up and to the right.
right.
C to D, it's concave down, but it's decreasing.
Mm-hmm. So,
And these are just, these symbols down here are just those words, but in symbols.
so then they're asking you, aren't they just asking you where it's concave down though?
And increasing.
Oh, I see.
And both are true. So that
B to C.
B to C only.
Okay.
I apologize if you hear the dogs barking. There's a little turf
Oh,
war
it's okay.
going on.
I can't really.
Okay. They're not even my dogs. Okay. Is it okay if we move on to question 5?
Yes.
Okay. I would, if I were you, it sounds like this graph question and then the one we did, some of these other ones, like the graph questions are going to be the most unclear for you going into the quiz.
Yeah.
Like this next question is a numerical analytical problem. I think you're going to know this really well. I would spend more time on
the graphs. Okay.
on the graph stuff. Okay. All right. Let f of x, let f be the function given by this, and they want to know where it's concave up. That's the second derivative. So you got to be really fast at taking a first derivative and then a second derivative.
X minus 12.
Okay. You set it equal to 0. You find, okay, that's at 2.
Mm-hmm.
Now I know this is multiple choice, so you can actually get rid of those because they've got the wrong critical point on there.
Okay.
So you make a sign chart here for the second derivative, and you test points. So like 0, 4, doesn't matter, and you're trying to figure out what's going on here. Is it positive or negative? So go ahead and tell me the sign here and here, on the left and the right, please. Whenever you get up to that point.
Wait, so just plug in the
You want to
the original?
No, not to the original. No. So you're testing. So what number do you want to test?
Oh, so you test like 3 and 1?
Okay, 3 and 1. They go back into the second derivative because this is the second derivative.
Wait, why do they go back in the second derivative?
Because you care about where it's concave up.
Oh,
and concave up is the second derivative.
Okay,
if you cared about where it's increasing or decreasing, we would do a sign chart on the first derivative, but we'd have different numbers also.
Okay, so you do 6 times 1. 6, and then 18. So it's negative for the 1 and then positive for the.
Yes, and I mentioned this yesterday, and someday this will make sense, is if you were to graph the line 6x minus 12, it would look like that. Okay. And so it's above the x-axis over here, and it's below the x-axis over here.
So then it's concave up from x is greater than 2.
That's right.
Okay.
There was a small thing here that seemed a little bit unclear. Let's look at the first derivative. I'd like you to find the critical points for me. So you're going to set this equal to 0. And let me know when you get those critical points.
Plus 3x. So it's 0 and 4.
Yes. Now the test points cannot be this, and this we're trying to like really get this down. Your test points cannot be those values.
Right. So you could do like -1,
okay,
2, and 6.
6. Now you're testing these because this is the second derivative, or I'm sorry, this is the first derivative sign chart. So that's what you test them in, you know, or this line here, either one.
Okay.
I like this line because it's factored form, but whatever the sign chart is for, meaning like wherever you got the critical numbers from, that's what you go back and test them. If you test 0 and 4, you're going to get 0 because that's what you just found in this line before. And that's why you test other numbers. So go ahead and tell me what's going on here in these intervals, please. Positive, negative, and so
So
on.
-1 is positive, and then 2 is, I have to finish testing them. 2 minus 4. So that's negative, but yeah, positive.
Again, I'm just saying, I know, repeat myself a lot, but if you were to graph this 3x squared minus 12x here, it opens up. And that's consistent with what you just showed me. Above the x-axis, below the x-axis, above the x-axis.
Okay.
Okay, so it's increasing from minus infinity to 0 and 4 to infinity, decreasing there.
Okay.
Okay, so let's try to only do what it asks so that we can get through these and then get some other stuff done. You actually did this either on that piece of paper. Yeah, I think that's what it was. You actually probably already know the answer here, that there are 3, but we can do it real quick.
It was the same one.
It's really similar. So the derivative is x plus 2. Well, maybe I should let you practice this.
Yeah, can I do that one? Okay.
Yes.
So
Take your time here and just let me know when you're ready.
4. Minus. Okay.
Are you ready?
Yeah.
All right. So the derivative is, you like to keep the first here.
Mhm.
Derivative of the second is 4x minus 3 cubed. Derivative of the inside function is 1.
Mhm.
Okay, plus, right, the second one, derivative of the first is 5, x plus 2 to the 4th, derivative of the inside is 1.
Yep.
And then you try and factor out. So you're going to factor out
Oh,
both.
I haven't factored it yet.
Okay. You're going to factor out an x plus 2 to some power and an x minus 3 to some power. And then we got to figure out what's left over.
So you can do x plus 2 to the 4th and x minus 3 to the 3rd.
Yeah.
So then you have an x plus 2 left over, you have a 4, and then you have a plus 5. Yeah, x plus 3.
Okay, so because it's just asking for how many critical points, not asking what they are, this gives you a critical point. This gives you a critical point, and that also does. Although you really probably should at least, like, you know, to go a little further here and make sure that the x's didn't somehow cancel. Get a really, you know, difficult instructor who warned you of that. They could make this cancel. So, but this does not. I mean, it becomes 9x minus 7. So that also is another critical point.
Okay.
It is a mistake to just justify like the answer on a quiz by, I did a bunch of them like this. You do want to go through this. Just warning you. You will see more of this in college. And assume you're already thinking about that or in the middle of deciding on that. But
yeah, waiting for decisions.
Yeah, so instructors in college, you get some that just mail it in, and some that really take the time to write really good test questions to see if you understand. So, okay, this one, they're giving you the second derivative. You know, that's really nice. Like, you don't have to take a derivative. Like, pay extra attention to making sure you like know what you're looking at. They want to know about the inflection point. So inflection points occur when the second derivative equals 0 and there's a sign chart. There's a change, like it goes from plus to minus or minus to plus. So we got to figure out, where does this equal 0? So f double prime of x equals 0 when x squared equals 0, x minus 3 equals 0, and x minus 6 equals 0. So at
0,
0,
negative, or 0, 3, and negative and 6.
right? And that's where you still got to make your sign chart here.
Okay.
And this one only has the second derivative. But that's what you test your points in.
Well, you test like -1. Yeah.
Negative
Okay.
1, 1, 4, I don't know, 8.
And then it's -1 minus 3 is a -4. -1 minus 6. So that's negative. 1 would be 1 times negative. This would be positive.
Yes. Yes.
This one would be 4 times. That would be negative.
Yeah, at 1 or which one?
Oh, what did I just say for 1? I already did 1.
I already did 1. Okay. Was 1 positive?
Yes, positive, negative. And then 8 would be positive.
Okay, good. So it only occurs when you go from plus to minus or minus to plus. So there's 1 at 3 and 1 at 6, but nothing at 0.
From 1.
Like, do you see how this goes from plus to minus?
Yes, that's the only one, right?
But no, the next one goes from minus to plus. That's
Oh,
okay
right.
too.
Okay.
So there's 1 at 3 and 1 at 6.
Okay. That makes sense. It's only when the sign changes.
Okay. Right. So where do we go from? Oh, you said you sent me some.
Well, I sent you those PowerPoints. I mean, there's like
No.
questions in them. I don't know.
I'm just gonna open up 5.3 and
Okay.
see if I find one real quick that.
Those are like the ones I've written all over, so sorry, but
That's good. That's good. You want to keep doing that, especially in college. All right. Yeah, let's do. This one's pretty basic to do in the time we have remaining, so we can at least have you look at it. Okay, so here is a thing. I want you to give me the first derivative and find the critical points, please. So let me know when you get your first derivative.
okay. You have to use like quotient rule or something for that first part.
I'm going to do a rewrite here. So this is -1/3 x cubed.
Okay.
So it is just power rule, and
Okay.
but that's why you do so many one way. You think, oh, it's more complicated than this. It's not.
So then it's, oh my God, 1/3. That's just -1 x squared. Okay. So it's negative x squared plus 2x.
Right. So what are the two critical points here?
Okay, so then you factor out a negative x, and then that's x plus 2. So 0 and -2.
You said negative x, didn't you?
Yeah.
So you have to factor that changes the sign of this one also.
Oh yeah, you're right. So 0 and 2.
Okay, so give me the sign chart here for 0 and 2. Tell me what goes on at each of those intervals.
Okay, so this one, 1, 3. So then you're plugging it back into the derivative.
Yes, because this is the first derivative. So your critical points you plug back in, never to the original. The original is when you're trying to find the mins or maxes.
Okay.
Like the actual what is the min, what is the max.
So then you're doing -1 squared plus 2. That's 1. That's a negative. That's 1. Oh wait, negative. Oh yeah, still negative. Three. Negative, positive, negative.
Yeah, and the graph of this, it's an upside down parabola. So again, like it looks like this. So negative, positive, negative. Okay. So what is happening at 0? Is it a min or a max? And then what's happening at 2? Is it a min or a max?
So 0 is a min.
Okay. And what's happening at
2
2?
is a max.
Okay, so what is the min?
Your
that means
min.
that means take that 0
Oh, I need to plug it in, huh?
and go find f of 0. Yeah.
Well, it's probably it's 0.
It's 0. Yeah, so it's kind of boring. But how about what is the max?
So you gotta plug in 2.
Yes, do that for me, please.
2 squared plus 2 times 2. So that's 4 negative 4 plus 4, also 0.
Yeah, you're plugging it back into the original.
Oh, wait, yeah.
Yeah, and f of 0 is still 0, so you got away with that one. But it's minus
so
2 cubed over 3.
This is more complicated. Okay, minus 2 cubed over 3. So that's 2 cubed is 8. Got that wrong last time. And then 2 squared. So it's negative 8 over 3 plus 4. Oh, I don't. Okay, so then that's negative 4, positive 4/3.
Yes. All right, so let's do now the second derivative. Y double prime is minus 2x plus 2. Okay, let's set that equal to 0. So x ends up equaling 1. And if we make a sign chart on that, I'm just going to go a little bit quicker here. It ends up being positive and negative. So this is an inflection point at x equals 1. But if I want the y value, you have to go back to the original.
1 into the original.
You have to find f of 1. So that's minus 1 cubed over 3 plus, what was it, 2 times 1?
Yeah, no.
No, 1 squared.
1/3.
Yeah, so it ends up being 1/3 plus 6/3, negative 1/3 plus 6/3 ends up being at 5/3.
So your coordinate would be like 1,
5/3.
5/3.
Yes.
Okay.
Like maybe, I don't think it's gonna be on this quiz, but like there is a curve sketching part of this course that
Yeah, I don't think it'd be.
you could be approaching. So good job on the lesson today. I think you got a lot out of it. Really study those graphs if you have time to do any more review. And that's it. I'll send you the notes here in the next few minutes and I'll see you next time.
Thank you.
Have a great day. Bye now.
Bye.